So the combo, complex numbers review, plus some other things we've struggled with a little bit in Unit 2. So we're going to start up here at the top with complex numbers. Now, quick review from yesterday. We talked about this imaginary value, okay, for if sometime I have a radical with a negative value, so I can actually figure it out. So I is the square root of -1. But the part we're going to be using up here in these first 9 questions, more often than not, is going to be what I squared equals. And I squared, if you think about it for a minute, you're like, well, that would just be squaring both of these, and squared and square root cancel. Oh, okay, that's the value that's going to bring a little more importance to us. Because anytime you see I squared, we're going to go ahead and replace it with -1. So when I get down into these first problems, I got to pay a little bit of attention to the signs that are there to make sure I don't do something silly. Like for instance, on 1 through 3, we're just combining like terms. They're just pluses and minuses there. So when I look at number 3, I see a minus, which means we've got a value that we're going to be distributing through. I leave that first part alone. And that minus here is just going to change the sign on both of these. So it'll become +4 and +7i. And at this point, I'm just going to combine like terms, and I'm going to be done. So I look, and I'm like, okay, let's see. -4 and +4. Oh, they cancel out. Okay, so there's no numeric value this time, no constant term. And then 6i plus 7i is 13i, and I'm done. Simple as combining like terms. Okay, but again, you've got to watch for the symbols. Because if it's not a plus or minus in the middle, like it is here on 4, once we get up here, now I'm multiplying. So if that's the case, 7 times 6 is 42. I times I is I squared. Ooh, I squared. I squared is -1. And -1 times 42 is -42. Okay? I should never see an I squared in an answer because we have a value for it. I's are okay in your answer, just not I squared. Okay? So when we're multiplying, we really have to be cautious to see what's going on as far as those go. Let me bump up just a little bit here. So we're going to take a look at 5, and then I'm going to start bouncing around a little more. Now, 5, still multiplying, but now since there's 2 terms, okay, if we have 1 term by 2, we distribute just like we normally would. So I multiply those guys together. Negative times negative is positive. Lots of little places that can mess me up. But before I circle my answer, there's I squared again. That's really -1. So positive 16 times -1 really is -16. And typically when we're doing these, we're writing them in what's called standard form. Normally we write the constant value first, then the I. Now is that one of those things where if this were the quiz and you wrote -24i minus 16, then I'm going to mark it wrong? No, because you still have all the right parts. Just looks a little bit different than mine. Okay? So again, no I squareds. I's are okay. So we've looked at just combine like terms. We've looked at monomial times monomial, monomial times binomial. One more. Number 9. Okay. Binomial times binomial. I can't just distribute this time. I need to FOIL this out. Now, we talked a little bit yesterday about trying to use organizational tools and things to make this go a little better. Some of you are very comfortable doing the little lines and foiling it out that way, and that's fine. But if that seems to get you confused or it gives you where you have an issue, I would suggest going this route. 2 terms by 2 terms. If I have 2 terms in each set of parentheses, that's when I got to FOIL it. Okay, if I only have one term by 2, like I did in number 5, then I can just distribute. Number 3, though, is minus. I'm not multiplying. Okay? So when I have to FOIL, okay, I'm just multiplying what's going on the edges of my box. It makes things nice to get like terms put together. And it also makes sure that I actually multiply everything and I don't lose a term somewhere. Now, before I combine my like terms and tell myself I'm done, again, look for I-squareds. So for instance, here I see, ooh, there's an I-squared, which is -1. So 4 times -1 would make this -4. So when I go to combine like terms now, -21 minus 4 is -25. 28i minus 3i, because I'm just combining like terms now, is 25i. No I-squareds. I have I in this one and no I here, so I can't combine them anymore, and I'm done. Okay. But it's getting used to looking at what I'm supposed to do and then doing it that way. 2 terms by 2 terms, we FOIL. Everything else, it's just distributing or combining like terms. And that's basically the basis of our complex numbers that we talked about yesterday. Yeah?
So for 7 and 8, you would FOIL it?
Yes. 7 and 8 definitely FOILed. So then, I get down here a little further. Okay, we're going to take a look at 10 and 12. So I get down here and I'm like, okay, I got to get my variable term alone, my a². So I divide by my 6. And then to get rid of the squared, I square root. You're like, innocent enough so far. But then I go to pull up my calculator to try and help me out. And I do the square root of -60. Uh-oh. Non-real answers. Does it mean I'm done and it can't be done? No. No. One of the things we learned yesterday with this wonderful thing I is, if you have a negative under a radical, you just pull an I out. Ooh. Hopefully that kind of sticks up in your brain. You're like, oh, got to pull an I out. Yuck. So this is going to be I times the square root of 60. I pulled the negative right out of there. So when I go to write my answer, there's going to be 2 answers. So it's plus minus. The question, though, is, once I pull the I out, can I break down 60? Okay. 2 numbers multiplied to 60, one of them has to be a perfect square. Ponder for a moment. Apologies for the delay here. Oh, never mind. There is no delay. 15 and 4. So the square root of 4 is 2. That gets to hang out with my I, because it's out of radical jail. And the 15 stays under. Nice. So again, just breaking down like we did before with square roots, except now an I might pop up here and there. So as we move a little further down, same thing when I get to 12. Got to get that guy by himself. What do I need to do first? Add 2. And you're like, okay, then I got to divide by -2. Negative divided by negative is positive. Now, here's one thing I don't want you to do. You're like, okay, I'm ready to do the square root. Okay, that's good. So I get here, and I do my plus minus. I do not want a decimal, okay? for people watching this that know that I should be rationalizing my denominator here, but that's not something we're stressing at this point because we haven't played much with that, I'm content with you leaving it this way.
I want to rationalize my denominator.
Okay, all of you heard that out there, so since Dylan wants that, we're going to do it. He's like, are you kidding? No, I'm not kidding. Okay, we're going to rationalize the denominator. So, here's how that works. I'm actually glad you said that. So, normally we can't have a radical in the denominator of an answer, and we do in this case. So here's how I fix it. Here's how I rationalize it. Whatever that square root is in the denominator, that's what I'm going to multiply the numerator and denominator by. So if it was 3, I'd do square root of 3. If it was 7, I'd do square root of 7. And I just multiply across. 5 times 2 is 10. That's still a radical, but that's okay. 2 times 2 is 4. What's the square root of 4? 2. No more radical in the denominator. We are rationalized. And thank you for pushing us to do the right thing. Okay. Now again, that's the only one of this type that you've got on here. So don't freak out thinking this is going to happen a bunch. It doesn't normally. Normally your biggest concern is, do I have to break down a radical sometimes? Sometimes we will, sometimes we won't. Okay? Other issues on page 1 before we go flipping on here with our adventure of I. Okay. So when we get to the back, we're going to start at 16. Again, we have an issue. Negative radical. Pull the I out. Pulling the I out gets it positive. Can I, hint, hint, break down the 54?
Yeah, probably.
Yeah, probably, since I already put the little branches in there. 2 numbers multiplied to 54. One has to be a perfect square. 9 and 6. So the one that breaks down nice, square root of 9, which is 3, hangs out with my I. 6 stays in. No plus minus here because we're not solving an equation. There's no quadratic. Just breaking this down, we're done. So we just leave it that way. Okay. So it's kind of funny that we rationalize the denominator on the first page because that's about what we're about to do here with I. So these next two, people normally do complain about it. It's too long, but we've got to deal with it. So when we rationalize a denominator, we're going to multiply by what's called the complex conjugate, but it's really not that complex. Basically, you're taking the sign of your problem, in this case, the negative, and we're switching it. So here, we're going to use positive 10i to multiply by. And this one's actually going to go quick. Monomial times binomial, which means I can distribute. So, 10 times 10 is 100, but I have an I. 10 times 5 is 50. I times I is I squared. And we'll come back to that because we know we can't have I squared in the answer. Negative 10 times positive 10 is a negative 100. And I times I is I squared. Now, we got to remember, oh yeah, we can't have I squared. That's negative 1. So 100i, 50 times negative 1 is negative 50. Negative 100 times negative 1 is positive 100. Now, before I circle it, I always got to think, is there one last little thing? Yeah, what are all of these divisible by? 50. Now, I heard a couple of you say 10. If you did it by 10, that would be okay, but then you'd look at it again, and you'd probably notice you could do it one more time. Okay? So you're like, well, what if I did this on the quiz and I left it like this? This is like a 3-point question. You'd probably get whacked like a half out of 3. Because again, you showed me you know what you're doing, We just got to make sure we get that detail work done. Okay? So that's how a conjugate would work on a monomial term, on 1. What about 2? Well, 20, yeah, 20 is normally the big griper problem. I'll admit it. Because here, switch my sign in the middle. So we've got to switch this to 3 minus 3i. And yes, once I take a look and I kind of go, oh, you mean I got to foil both of them? I got to foil these and foil these? Yup. Okay, again, it's not a ton of them. It's just sometimes something we got to do. So again, I'm going to multiply this out. I'm going to foil it out by any means you do. I, again, like the box because it keeps me organized. And I'm just going to kind of whip through here. Multiply those sides together, being very careful to make sure I'm not losing parts as I do it. And before I write this up here, I look, do I have I squareds? Ooh, I do. Okay, negative 21 times negative 1, positive 21. And now I can combine my like terms. 30 plus 21 is 51. 21i minus 30i is negative 9i. And I do it one last time for the denominator. Now, you're going to notice something when we do this for the denominator, which is going to be true every single time you do one of these. So hopefully that helps you shorten things up a little bit. We'll see. So I'm doing it one more time. And I'm multiplying through. Once again, I see an I squared. Got to fix that. Negative 9 times negative 1 is positive 9. So let's see here. 9 plus 9 is 18. Positive and negative 9 cancel. That's the way it's supposed to work. And I'm set. Now again, there's a small detail issue here. These are all divisible by 3. So it's one of those where if I forget that, it's not going to be the end of the world. It's going to be a very small thing to deal with. Okay? Because again, if you show me you've got the concept down, that's what I'm really looking for to make sure we're feeling all right with that. So we get that set. We're going, okay, you know, there's steps to this. It's not that they're hard steps. It's just I've got to get used to it. I got to get a little practice so I feel better with it. Okay, factoring. Now we made a comparison yesterday. We were doing this to difference of squares. So I'm going to use 22 as my example here. If this said r squared minus 25 instead, and I think back to my green sheet, I'm like, ooh, they're perfect squares. It's a difference of squares. That would look like this. So it'd be r plus 5, r minus 5. The only difference with this is that now it says plus in the middle. Does that mean these are both plus? No. Here's how this works. I'm still going to write r plus 5 and r minus 5, but to make the sign switch to a plus 25, you'll never guess what we're going to put in. Now we're not going to pull an I out. We're going to put an I in. You're like, wait, why would you do that? And do I have to do any more? No. And here's why I do it. Okay, if I were to take this and foil it out, box it out, check out what happens. Negative 25i squared becomes plus 25. And my middle terms cancel out. Positive and negative 5ir. R squared plus 25. It comes back to me. So whenever it says factor and you're seeing a plus in the middle like this, the only thing you have to do different from what you would do normally on a difference of squares, plop an I on there. You're good. And those other two, exactly the same thing. What do you square to get each one? Put a plus and a minus with them. Slap an I in there. Nothing too bad. Nothing too bad. Little strange, but not too bad. And I apologize on 25 and 26. My computer was acting up yesterday and wasn't letting me do like exponents here. So I'm going to rewrite this so it looks a little more normal. That's better. Now this time, I can't get to my x. The parentheses are there. So, got to get rid of that part first. I got to do it a little out of order. So whack those guys. Because again, they're inverses. Not a negative this time. No pulling i's out. We don't have to go to extremes except when necessary. Plus, minus. Oh. Okay, it will be, yes, because it's 4 and 6, and the square root of 4 is 2. So 2 square root of 6. And again, this part comes from practice, breaking down radicals just like anything else. And then I just got to get my x by itself. And I'm set. So, I mean, there's lots of little things that can nab you for partial points if you're not careful. The plus, minus, not breaking down a radical, you know, that kind of stuff. But as the more, again, we get some practice with it, the easier it's going to get. And it is. Lots of things to keep track of. All right. Now we're going to go into review mode. Because you've seen we're kind of getting away from I here and going back into things we struggled with on the last quiz, and we're going to see some again on this next one. All right, back to one of the things we were good with, completing the square. Oops, if I move this down a little more, we'll be solving. There we go. So solve by completing the square. To complete the square, when we're solving, we want to get our variable terms alone. So I'm going to get the 20 out of there by adding it over. Then it's our little thing from our little jingle, our little song from before. Okay, we have b. We square half b. We add it here. We add it there. Whenever I'm doing completing the square and I go to add a value, I've got to do it to both sides. Otherwise, I don't have balance anymore. Once I have that balance, the only thing left that can screw this up, what value goes with p in the parentheses? Positive 3. It's the b divided by 2 value. And now it looks just like the problem we got done with, the last one. So I'm going to do it the same way. I'm going to do my square root. Got my inverses working. I find out that 29 does not break down. That will happen sometimes. Sometimes it'll break down great, sometimes not so much. And I'm going to minus my 3 over to get my p isolated. And I'm done. But I've got to remember the whole, you know, half b square half b. Okay, I already told you I wouldn't make you deal with that again, so I won't. But again, as I'm working through that, that's the process I'm going to be doing. Now, we did completing the square 3 times. We did one where we're solving, which we just did. We did one where we're writing in vertex form, where we're trying to get it looking like this, where the concept's the same, the adding just is a little different. When there's a y there, we're going to put a blank on the y side, because that's one place we're going to be sticking a value. And the x's normally like being by themselves, like they were in 27, but sometimes that's not possible, so instead, they just build a wall of parentheses to get the 12 out. Okay, I can't move the 12. Moving the 12 will not work. It will not help me. It'll just make an extra step for me later. But then the process is exactly the same. Take my b. Have it. Square it. Use parentheses. Okay, I never should get a negative value when I'm putting that in on both sides. If I do, I forgot the parentheses. That's the only way that can happen. And actually, I'm going to be one step from being done at this point. Hard to believe, but very true. So I'm like, okay. Going to go to my binomial form, just about there. Get my x there. What goes in with my x? -4. I have b. See a pattern developing here? Almost the exact same thing now. The only difference is this is just y equals. So I've got to get the 16 out of there. And if I wanted the vertex, I could get it now at 4, -4. And work it that way. But again, the forms do change things a little. The steps don't change. It just changes where I'm adding my values in. So that was our second way of doing it. Okay, one more. Center and radius of the circle by completing the square. Now this was actually the one that takes a little bit of the longest time. So I'm going to put my x's together with a blank. All about the blanks. Put my y's together with the blank. And we don't like the constant term. We only want variable terms. So I'm going to move that 14 to the other side. Oops, this was supposed to be minus. That should say -14. I apologize. Let me get that situated. And now I just do my completing the square process for my x's. And I got to do it for my y's. But again, it's the same thing. It's just kind of repetitive. So I look and I'm like, okay, -2 divided by 2 is -1, and square it. Add that to the other side. Again, balance. Add it to one side. I got to add it to both. There's my b term again. Have it. Square it. Add it to both sides. And again, it seems like I've done a lot, but I'm one step from being done. It's not like there's a ton left for me to do. I get it into my binomial form. Just steal the number that you did, b divided by 2. Same thing for y. Steal my b divided by 2. And I'm in my circle form now, where I can find my center. What would my center be? 1, -3. Because again, it's x minus x in the opposite of h, y in the opposite of k. And my radius, since that's not a perfect square, would be the square root of that value. Now again, we don't really want to do a decimal here, and if you left it that way, I would not scream and yell. Okay, if you left it as that, not going to scream. I like it a little better broken down, but if I don't have it broken down, I'll live. But again, nothing that's awful. And we're just really locking down and making sure that we've got the general concept down, especially completing the square. Now to put some of you at ease, when we get to the quiz, there's a question on the quadratic formula that will be given to you, okay? Because again, I want to see if you can use the information to get it out. Okay, so there's the formula I'm using. But here's the thing that I've got to make sure of, another one of those details. Before I can do the quadratic formula, I've got to make sure my equation is equal 0. If it's not, my signs are going to be messed up. So I need everything on the x squared side. So I get equals 0. And I want to write them from the largest degree to the least. So squared x constant. Because those are my a, b, and c values. So I kind of roll on here. And I'm like, all right, let's do this. Opposite of b, opposite of negative 11 is 11. Square root of b squared, use parentheses, minus 4ac all over 2a. And again, I'm going to crank this out, this piece, on the calculator. Okay, don't try doing the square root right away. Just type in what's underneath it. Okay, we'll kind of give you the Cliff Notes version here. Let you fast forward a little bit. Underneath there, you're going to put 361. Nice thing when you get 361, after we clear that out, because you're like, oh my gosh, am I going to have to break that down? Or, oh, it's nice. Okay. But I can legitimately get two answers. If it's a radical, I'd have to just leave the radical and I'd be done. But it isn't this time. So I do 11 plus 19, which is 30, over 4. And I don't care if you go to a decimal, fraction, whatever on these. Okay, if you go to a decimal, that'd be okay. It'd be 7.5. 11 minus 19 is negative 8. Divided by 4 is negative 2. But again, the formula will be there, so don't freak out. Okay, don't panic. We'll have you set. Finally made it to the back page. Now, don't go snoozy on me now, because these last two questions are coming back again, and if you miss them, if you blow them off, it's going to be 5 points worth. And that can be kind of tricky here. So it says, find the 0, and it reminds us of the calculator buttons, because Jen throws a softball up in the air. The height of the ball can be modeled by this function where x represents the time elapsed in seconds. Use the quadratic formula to identify when the ball hits the ground. Okay, here's where I'm going to break my own rules. Use any means necessary. You're like, what does that mean? Okay, if you want to use the quadratic formula, A, B, C, and just plug it in and crank it like we did in the last one, that's fine. Okay? You'll get the right answer. But we also have learned in here a way that I can do it by punching it into the calculator and doing the graphical way of doing it. You have options here, and I want you to use the one you feel more comfortable with. So if I punch it in the calculator, I hit graph. That is the value I'm after. Okay? Because that's a positive 0. That's a negative one. That doesn't make sense. So again, like it says at the top, I can do second, trace, up to the 0. Okay. And remember, when we're doing these, if we go at it graphically, okay, that's the point I'm looking for. I got to trap it. So I'm going to take a positive y value, like I have here. I'm going to hit enter. I'm going to lock that spot in. Then I'm going to pick a spot that's a negative y, that's below the axis. Again, just using the right button. Okay, there's a negative. I'm going to hit enter twice, because now I'm going to trap the 0. So it's going to take like 0.78 seconds. That ball didn't get thrown very hard. I think we got a weak arm here. But again, I could plug that into the quadratic formula too, with those 3 values, and get the same answer. So find something you're comfortable with and work it, especially since you have multiple options. And finally, the other problem we had issues with on the last quiz, okay? The area of a rectangle is 96 square meters. The length is x and the width is x plus 4. Find x and the dimensions of the triangle. Okay, area is length times width. So, what do I know? Well, I know length, I know width, I know the area. So here's what I need to do. And again, I have options. One way or another, I need to distribute that through. And this time, if I'm going to use factoring, and I actually think factoring is the simplest way this time, I need all my terms on the x squared side. I had people ask me last hour, could I do completing the square on this? Sure, that would work. Could I use the quadratic formula on this? Sure, that would work. But I still think in this case, factoring is going to be the easiest if I get this to equal 0. Because I don't have to use slide and divide. It's just x squared. And I just got to play on the calculator a little bit. So I'm like, okay, I need two numbers that multiply to negative 96 and add up to 4. Well, if they multiply to a negative, I know my product is going to be one positive and one negative. And I know they're going to be 4 apart from each other. So if I got to start playing a little bit with the calculator, nothing wrong with that.
Mr. Hardy,
Yeah,
can I please take
Sure.
that for 2 minutes, not more than that?
absolutely.
Thank you.
So I start to mess around with these. Okay, 2 and 48. Well, they're not 4 apart. That's not even close. Okay, I guess we need to start using bigger numbers here. Let's try 6. 6 and 16. 10 apart. We're close. Let's try 8, because I know 7's not going to go in. It's odd. 8 and 12. There we go. 8 and 12 are 4 apart. Okay, it's plus 4, which tells me the bigger number is going to be plus. Okay, no slide and divide. I don't have to worry about dividing through. That's a good thing. And so I just set this equal to 0. And I solve the two mini equations. Now be careful for two things here. One, we're finding the sides of a rectangle. Do both of my answers make sense? No, negative doesn't make sense for a side of a rectangle. So, okay, there's x, that's good. And find the dimensions of the rectangle. In other words, what do the length and width equal? Well, the length is x. Okay, so the length is 8 meters. My width is x plus 4. 8 plus 4 is 12. Alan, 12 times 8 is 96. I'm good. Now, like I've said before, use this, even though it's on the homework check, use this more as, okay, here's the area I struggled in. I was bad on 35, 37, and X, Y, and Z other problems. Then just practice in those sections if you feel overwhelmed with doing more than that. But the more you practice, the easier this is going to be when this quiz is in a couple of days. And I've said it before and I'm going to say it again. If this is all you do and then you shut it down and don't do anything again until tomorrow, you're going to reset all the way back at the beginning. Until you reinforce it, it's not going to get better. And I'm going to keep seeing IDK, I don't know, this sucks. And I'm going to keep getting middle fingers drawn on papers, which again, when you don't practice at it, it middle fingers right back at you, to be perfectly honest. So practice it, work at it. We've got keys. You can ask me questions, and we'll get you set.